Thank you, Magnus, for a really nice introduction. I have to say I've only been here a couple of days, but it's been beautiful and very warm welcome and very hospitable. And so thank you very much for hosting me. Thank you for this really nice weather. I spent 14 years in Panama and another 9 years in Southern California, but I grew up in New England and I miss snow. And so I feel like I'm having a very Swedish weather event here, which is nice. What I'd like to do is tell you a little bit about the work I've done over, actually some of the stuff stretches back to when I was a graduate student, all the way to the present, and tell you about my thoughts about coral reefs today, what they used to look like, and what they might look like in the future. It's actually the other thing I'd like to say, it's a real pleasure to be here because at Scripps, I founded something called the Center for Marine Biodiversity and Conservation, and it was really modeled on the Bayesian Institute in a way in terms of the topic. So it's really inspirational to be here and see the thing in flesh and blood. So, okay. So this is the way that Discovery Bay, Jamaica, which is the north coast of Jamaica, looked when I was a graduate student. I hate to admit it, in 1975, I was a very precocious graduate student. I was only 4 years old at the time, so not really that old. But as you can see, for those of you who know corals, all this stuff is living coral. This is living massive corals, living branching corals, and the percent coral cover on the reefs was about 70%. Now, we knew these reefs weren't in perfect shape. In fact, you can see that from this photograph as well, because these are the only fish you can see, and these are plankton-eating fish. They're only a couple of centimeters long. So it was a very overfished reef. All of Jamaica was overfished because of extreme poverty, basically, even in 1975. But the corals themselves were in beautiful condition. And because of a series of events, which I'll say a little bit more about tomorrow in my opening remarks for the thesis defense, those reefs essentially vanished, and they became seaweed reefs, which you see here. Essentially, the whole bottom was covered with macroalgae and only about 5% living coral. So we went from 70% living coral to 5% living coral over the course of my early career as a scientist, beginning as a graduate student and an early assistant professor. So it was a really dramatic phase shift, which we'll be hearing a lot more about tomorrow. Unfortunately, this was an event that was sad enough to have it happen in Jamaica, but it wasn't limited to Jamaica. This is a meta-analysis of what's happened to coral reefs over the last 30 years, and you can see that on average they went from a little over 50% coral, again, to about 5% living coral. And there were a number of things that happened. There were big disease events, the diadema die-off, which is a sea urchin that was responsible for keeping seaweeds under control, bleaching events. But there's it all adds up to about an 80% decline over the last 30 years, which is huge. It's really rivals anything we've seen in terms of tropical rainforests, in most part, in terms of ecosystems that we worry about. This is as bad as the worst tropical rainforest stories that we have to tell. And it wasn't even limited to the Caribbean, although the Caribbean is a kind of worst case scenario. Even in the Pacific, where of course most reefs occur, if you think of this as a trajectory from large amounts of coral to very little coral, the Pacific reefs are not that far behind. They're at about 25% on average living coral across the Pacific, including places like the Great Barrier Reef, which we consider to be models of ecosystem protection. So although they're not as bad as the Caribbean, they're not in great shape. And perhaps it's not surprising, given all this, that in 2008, it was declared that about 1/3 of all corals are at risk of extinction due to a combination of climate change and local impacts. So the situation for reefs is really bad. Now, why is it so bad? Well, it's actually, in retrospect, it's not too surprising that reefs are in bad shape. And in fact, this is not really a problem just limited to reefs, although reefs are kind of the quintessential example of marine ecosystems being in crisis. It's not only reefs that are a problem. And we basically have a situation where you have carbon dioxide in the atmosphere causing global warming and ocean acidification, nutrients in the coastal ocean, toxic materials sediments associated with poor land use and coastal development and deforestation, and even invasive species on the input side. And on the output side, we're essentially taking out anything bigger than about 5 centimeters. So we're doing this massive bottom-up, top-down experiment on the world's oceans, and it's not too surprising that reefs are in a bad way, and there's an ever-growing list of problems associated with reefs. And you can see some of these problems here. We have disease outbreaks, we have smothering of reefs from sedimentation, we have the invasion of really nasty Indo-Pacific fish predators that are compounding the problem of overfishing by eating up whatever we don't eat. These guys are happy to finish the remains. Coral bleaching, which I'll talk some more about. Predator explosions. These are crown-of-thorns starfish, which are capable of eating 95% of a reef over the course of a couple of months. We have acidification, overgrowth by seaweeds, as I mentioned, and even storms. Now, people aren't the major cause for all of them. Obviously, there have been storms on coral reefs for a long time, but in one way or another, people contribute to the problem, even in storms, by virtue of global warming making storms more intense, if not more frequent. And in some of these situations, the human footprint is the only footprint there is. These are completely human-caused problems. So what I'd like to do is talk about a couple of them in a little bit more detail. The first is coral disease. And you see here some examples of coral diseases in massive and branching corals. Corals normally, a healthy coral is brown colored because of the symbiotic algae that live in the tissues. So when you see white like this, that's a bare, dead skeleton that's being revealed. So all this white area is actually bad news. So this is white band disease, named for white band, of course. This is black band disease. This is yellow band disease. This is white plague, and I don't even know the name of this one. And I think you can tell just by these names that we don't really know much about what causes these diseases. In the United States, we have something called the Center for Disease Control, and they have departments of heart disease and cancer, but we're sort of at the stage for coral diseases as if we had departments of stomach aches and headaches and backaches. We're just talking about, these are symptoms. These are white bands and black bands and yellow bands. We don't, for some 30 some odd disease, types of disease that we've reported on coral reefs over the last couple of decades, we really don't know the causative agent in the vast majority of them. And as you'll see in a second, there may be a good biological reason for that, but still only about 6 or 7 diseases have a well understood causative agent.